So with this example, it reads as follows. A train of mass 500 tons has a maximum speed of 90 kilometers per hour while it's moving up an incline of 1 in 50 against frictional resistance of 100,000 newtons. Find the maximum power of the engine. So before we reach the solution, we need to understand everything in the question. So first of all, the train has a mass of 500 tons. Remember, each ton contains 1,000 kilograms. So that means the train has 500,000 kilograms and it's moving at a maximum speed of 90 kilometers per hour. So we need to change that maximum speed from kilometers per hour to meters per second. And when we change it, it becomes 25 centimeters. Then a frictional resistance, which is 100,000 newtons. That's the force, frictional force, which is opposing the motion. And remember, this car is moving upwards. So it means there is a driving force which is making it to move upwards. But that driving force is being opposed by the frictional force. And that driving force is brought about by the speed that car is moving with and the force applied. So that is the power for that case. So when they say that we have maximum speed, we mean the train is moving with a steady speed or a uniform speed. So that means the train is not accelerating. It is moving constantly with that uniform speed. So when we come to solve our question, they want us to find the maximum power. Remember, power from our formula, power was Fv, force applied times the velocity with which that body is moving with. So that velocity this time around is the steady or maximum velocity. So we shall have to look at the driving force which is making the body to move upwards. That is capital F, which is upwards. Then the friction is opposing motion. But remember, due to the weight of this train, there is also another force, mg sine theta. It's also downwards. It's that force is downwards. So there are two forces which are opposing the upward motion of the car. So that means we can get the resultant force or the net force. So the net force is the driving force, capital F, minus the sum of the two forces, frictional force and mg sine theta. Okay, so when you simplify, you'll have to get the driving force. But remember, theta or sine theta, we are sine theta is equal to the sine inverse of 1 over 50. So sine theta is just 1 over 50. So when you come to substitute in this formula, net force is equal to F, capital F, which you don't have, frictional force, you have it. Frictional force, you had it. It is 100,000 tons. Then the weight was given as 500,000 kilograms. And G is always, you have to say 9.81. Then you know that the net force, or you can call it the resultant force, is given by MA, mass times acceleration. Mass of that train times its acceleration. So when you substitute everything, you'll have the driving force or as 198,100 newtons. Then if you have the driving force as that, then you know power is Fv. So substitute F as 198,100 newtons times the maximum velocity, which was 25 meters per second. So when you multiply the two from the formula of power, you'll have the maximum power being 4,952,500 watts. Or you can put this in megawatts or kilowatts, no problem. The second example, you can take time and look at it. Take time and do it on your own. It's very simple indeed. Thank you very much. Have a good day.